Hey guys, yesterday we talked about functions. Now we're doing even more functions. Just really part two of the same. Two special things here. Only two things today, but really got to watch them closely. Here we go. The first one, they're going to give you a function like the one in this problem. F of x equals 2x squared plus 3x minus 1. It's going to say evaluate. First, we're going to do f of a. Matter of fact, we're going to skip this one. We'll do f of a plus h, and then this big old thing right there. Okay, so hang in there, buckle up, here we go. F of a you find just by plugging in the a's where the x's were. All there is to it, there's f of a, piece of cake. F of a plus h is going to take a little bit longer because we're actually plugging in the a and the h, so it's going to look like this. Plug in the a plus h here and square it. Plug in the a plus h after the 3. You still got the minus 1. Now, the bad news is you got to work all that out. Okay, so I'm going to square the a plus h. Remember how you do that. Square, multiply together, double, square. I'm going to distribute the 3. It's getting huge. It's okay. And now I'm going to distribute the 2 and I'll be done. So distribute the 2. I get 2a squared, 4ah, 2h squared, plus 3. I'm giggling because it's so long. 3h minus 1. There we go. There's this one. Wow. All right, now, the reason they made you do those two is so that you could actually do Part D. Part D you're going to see a lot this year. It's called the difference quotient. We're going to use it quite a bit as we go on. And you got to do f of a plus h, which we just did, by the way. F of a plus h is this, minus f of a, which is that, and we're going to put it all over h. So that's what I'm going to do right now. So Part D, I'm going to do f of a plus h, which I'm going to recopy what I just wrote. All right, this is what I got when I did f of a plus h. And then it says to do this. It says subtract f of a. So I'm going to subtract out this first answer. And if I subtract it, that's going to change the sign. So I'm going to make it negative 2a squared minus 3a plus 1. And guys, that's all going over h, just like it says up here in the problem. So before you pass out, look at what we have here. The 3a's are going to cancel. The 1's are going to cancel. The 2a squareds are going to cancel. Stuff is going to cancel a lot. Okay, so look for stuff to cancel. What that leaves me with is a 4ah, a 2h squared, and a 3h all over the h that's still on the bottom. And I would be done, except one thing I notice is every single term on the top has an h. So I'm going to divide that h into the top, or my numerator, and I get 4a plus 2h plus 3. That's the final deal. All you got to do is that right there. So that's why they broke it down for you. F of a plus h, and then do the difference quotient. All that stuff put together all over h. All right? It's going to be fun. One more thing. Last thing is domain. Find the domain of each function. There are only two times you ever have to worry about domain. One is if you have a fraction with an x in your denominator. The other time is if you have an even root, like a square root, fourth root, etc. So what you're not allowed to put in for x when you have a fraction is no value. You cannot let the bottom equal 0. You can't let the denominator equal 0. So what I'm going to do is I'm going to factor the denominator, make it x plus 1, x minus 1, difference of squares there. So what that tells me is I cannot use negative 1 and positive 1. I cannot plug those in for x in the function. Because if I did, it would give me 0 in my denominator, which I can't have. So my domain is everything except for negative 1 and 1. The way we write that is a little squiggly. And that means all x such that x cannot equal negative 1 and 1. All right, so x can be anything you want it to be except for negative 1 and 1. Now the second one's actually a bit easier. The only restriction for a radical is you have to have a positive number inside, or 0. It has to be 0. It has to be non-negative. It has to be 0 or positive. So to find the domain here, I'm just going to take what's in there, that x minus 5, and say it's got to be either greater than or it can be equal to 0, one or the other. So I'm going to move the 5 over. X is greater than or equal to 5, and that's the domain. No matter what I plug in there, whatever x I plug in there has got to be bigger than 5 or equal to 5. So I'm going to write that like this. All x such that x has to be greater than or equal to 5. And that's it. Okay, so the domain is going to be a little bit easier than the function plugging in probably, because there's only two times you got to worry about it. If you get a function with no fraction or no radical, it's just all real numbers. Okay, piece of cake. All right, don't worry about it. We'll work on this tomorrow. We'll get good at it like we always do. Can't wait to see you. See you then.